Hello everyone. I recently read a research article online. I'm very happy to present my research paper on the title of Water Distribute Control Systems or Components-Based Design Method for Mechatronic Systems. And next, I will introduce this research article from 5 parts. We can see the first part is introduction, the second part is theory, the third part is the simulation and results, the fourth part is conclusions, and the fifth part is references. Let's see the introduction of the first part. To realize an effective and coherent strategy for designing and building DCS, which can be used within mechatronic systems. A new approach is proposed utilizing a components-based paradigm. And then we can see the theory of the second part. It consists of many devices and a few bars. A device is a copy of a component, which stands for the device type. This is similar to the concept of component, e.g. 1 kilo resistors, and device, e.g. R1, R2, etc. in electronics engineering. Each device has an individual device name and identity. Identity means ID here, which is used to distinguish different copies of the same component. All the devices communicate each other via fieldbus. The fieldbus is the linking among the devices and is similar to the connection wires on printed circuit board. Printed circuit board means PCB. And then you can see it consists of many devices and a few bars here, and all of the devices communicate each other via few bars, just like this. Okay, and then we can see a component can be a basic component. Basic component means BC here, which cannot be further decomposed, or a compound component. Compound component means CC here. A CC may consist of 2 or more BC. You can see it. This just one and just one or more BC. A realistic property of a component is the usability. For example, a building automation system may have many temperature sensors with the same I/O functions. This means that these temperature sensor devices are the copies of a temperature sensor component. Each temperature sensor is called a device. A device has its device name and ID. And we can see it. Figure 3 shows the composition of a component. Includes 3 parts. 1. An image of a component. We can see it just like this. Water component. 2. A physical part. Means real component. Just like this. And 3. an I/O function database, and just like this. And next one, the image of a component can be considered as a black box. The functions of a component are embedded within the black box. The visible aspects for a control system's designer are the incoming and outgoing events. We can see it. This part are the input events, just like this. And the middle part can be regarded as a black box, just like this. And this part are the output events. And next, Figure 5 shows the structure of an application program. Obviously, we can see there are two parts here, just like this. It has two parts. Just one I/O function interface and events processing. I/O function interface and events processing. The I/O function interface is used to set up the relationship between the external and internal information. The events processing part may have one or more models, include control model, sensor model, etc. The control algorithm, e.g. PID, and some others corresponding to I/O functions are embedded within the control model. And next, Figure A shows the framework for the design and implementation of components-based DCS, which includes a set of defined rules for decomposing the system. Just like this, the rule for decomposing a system, and components libraries, just like this, a few bars and a set of development tools, just like this, toolbox and few bars. Right? Okay, next. About simulation and research relating to the program written by users. The SAV can find a guide wire, follow a guide wire, drive free to a distance, drive free to a plate, flow a wire to a plate, drive on a wire to a cross, and drive on a wire to a distance. And the operator can manually control the SAV, includes drive speed, drive direction, forward or reverse, steer to left or right, and emergency stop the SAV. The working status of the SAV can be displayed on includes 5 indicating lamps, LCD display window, and SAV event log, and then a better safety system includes side-borne sensors, laser scanner, non-contact collision warning and protection, emergency buttons, and protecting the SAV from operation when it's charging. The last and most important part, computer assist development tools have long been their search area in the control domain. This paper introduces original work on specification requirement of computer-assisted development platform. In terms of virtual DCS environment, therapy control, prototyping of mechatronic systems. The research motivation comes from the fact that from control architecture point of view, most of the mechatronic systems are distributed in nature, and presently available tools and systems do not provide operational virtual features as far as real-time distributed control network is concerned. This part is references. There's too much content, so I will read it one by one. Okay, that's all. The above is all my presentation. If there are any errors, please criticize and correct me. Thank you. Thank you so much. Thank you for your listening.